Hi everyone, I'm back today with another educational video, and the topic of today's video is the Flora Forms, the Bitcoin Ordinals collection by Harto, which successfully minted out earlier today, my time. I had to get up at 3 a.m, but that's the way it is when you live in Sydney. So big congratulations to Harto and the team, and today I'll be going through the collection and the techniques that they've used to optimize and reduce costs. They do make use of a lot of optimization techniques, so it'll be really interesting to see how it's all put together. So the collection itself is on Magic Eden, and it's done almost 17 Bitcoin in volume, which is really good. So I think it's been very widely it was very widely anticipated by a lot of people, and there's a lot of secondary trading going on, which is nice. And I think there would be a certain amount of people who are flipping, but then other people might be picking up pieces that they prefer in terms of color combinations and things like that. So the specific Flora form that I received is this one. And what we're going to do is use ord.io, which makes it quite easy to look behind the scenes and look underneath the actual image and look at the coding. So what I'll do is I'll copy the inscription number, which you can see here, and go to ord.io / and the inscription number. And this is it here. Now, this interface, this Explorer, gives you a couple of options. One is to open this in full screen, which it will take a little while, but here it is. Now, the reason why it took a little while was because the file size when I downloaded this was 15 megabytes, which, if you are familiar with the Ordinals system or protocol, you know, or Bitcoin rather, you know that 15 megabytes is impossible to do in a single transaction. So this is the output of code, and we'll see just how efficient it is. So I'll close that tab. Now, if we click this button, this will show us the code behind this image. And before I do that, just have a look on the right hand side here. You will see that the file size is 160 bytes, which is tiny, and you'll see it right here because it's made up of around about 9 lines. Now, this inscription uses a technique called recursion, which basically means that by using this particular tag, it is able to pull in content from another inscription, which is identified by this. So you can go to ord.io / and paste this part. And when you press enter, it will load the relevant inscription. So rather than using the number, you can use this ID as well. So I've done that already, and the content is like so. And the first thing you might notice is that there is a whole bunch of gibberish. It's not actually gibberish. It serves a very important purpose. But as we scroll down the file, we'll see it's quite large. It's a big chunk. And then once we get past it, we will see a couple of words in English. So if you're familiar with scripts or coding, you will recognize some of this stuff. And right down the bottom, you will see there is a function that also calls on 2 other inscriptions. So this is calling this, which in turn calls 2 other inscriptions. So I might go over these 2 first because we are on the topic of including other inscriptions. So the first one here, if we do an ord.io / and visit that, it is this particular inscription. When we look at the code, there is some CSS, some functions there, and then we see once again this big chunk of text or gibberish, and we'll work this out in a little while. And the second inscription that it's fetching is this one, and this one is entirely made up of gibberish. So what is this stuff here? Now, if we go back to the first inscription that's called, you will find that in the function there is a word called g_unzip. So this is referring to a library called gzip, which allows you to work with compression and decompression. So if you put two and two together, you'll probably realize that this here, this big chunk here, is actually compressed text. So I can go and copy this, which I'll do, and then paste it into a gzip decompression tool, which I've got here. And you will see that once it's decompressed, on the right hand side here, it's just normal script. The thing to notice here is that the file size when compressed is only 10.9 kilobytes. In its raw form, it's 35.5 kilobytes. So it's saving a lot of space already. And if we look at those other two inscriptions that had similar kind of text, if we copy this might take a while because it's quite big. Bear with me. And we're going to go and copy and paste this into that same tool and see what this gives us. So let's find out what this is. So I've copied that, paste, and the decompressed text tells us that it is the 3.js library. And if you've come here from the On-Chain Monkey community, you would recognize that this inscription is indeed the parent inscription of the dimensions collection, etc. So if we go down to the right hand side, the lower right hand side on this Explorer, you will see that there are child inscriptions. And if we click any random one, you'll see a dimensions come up. So shout out to Danny and the On-Chain Monkey team, a big rise there. So basically what this is allowing Harto to do is leverage something that's already on the blockchain, on the Bitcoin blockchain. So this was a 250 kilobyte file. So Harto doesn't have to spend the money to inscribe this because it's already there. It's reusing parts basically. So instead of, that's why his code here for the Flora form that each of us have, or if you were able to mint, is so light and can be done in 160 bytes. So let's go back to that compression tool and have a look at the savings as well. So uncompressed, it's 707 kilobytes, and compressed is 244 kilobytes. That's a big difference there. And the other one that we saw, which the whole thing is just compressed code. So I'll grab this as well, and we'll go and see what this is. So back to the tool, copy paste, and decompressed. This is the p5.js library. So 3.js works with 3D modeling inside your browser. p5.js is predominantly 2D, but it can do some 3D. But I believe that 3.js is the go-to for advanced 3D work. So back to my Flora form. Now we understand that inside of 160 bytes, we are calling this inscription, which is calling two other inscriptions, which we now know is the 3.js library and the p5.js library. So libraries that help to draw, basically. And then the code, the compressed code that's part of this one, we saw, and I'm going to use it again, I'm going to reference it again, so I'll copy and paste it. We saw is the actual script that draws the output. So if we have a look at some of the variables, they'll be quite self-explanatory. So you've got variables like flower layer, leaf layer, canvas size. We have an array of tulips, the colors of the tulips, and there are 8 different colors. And we've got things called greens and goldens, and we've got palettes and stuff like that. So this is the actual JavaScript code that generates the image, helped by the 3.js and the p5.js that you see towards the bottom. Now, at this point, I want to mention that each of the Flora forms has a parent. So it's been inscribed in a parent-child collection. So each of these are children of a parent. And the parent is, of course, it makes sense, the inscription that contains this code that creates the image. So what we just went through is inscribed onto here, and this is the parent. And you'll see that by scrolling again, like we did with the 3.js, and we saw the dimensions underneath. If we go to the bottom of this one, you'll see all these child inscriptions. And if we click on any of those, you're going to see a Flora form. So the parent-child relationship creates trustless on-chain provenance, so that if anyone were to try and sell you a Flora form for a ridiculously cheap price, or they wanted to do a private deal over the counter, they want to avoid fees on Magic Eden and stuff like that, the usual scams, you are able to yourself verify that what you are being sold or potentially sold is indeed part of the official collection. So all you need to do is you would get the inscription number that they're talking about, go into ord.io / paste the number, and you must have a parent inscription of this particular specific number. Only then it is official. So I'm going to go through and next talk about the actual postage value, the sat size, sorry, the output size that these were inscribed on. Because when you create an inscription on an ordinal, you use the Ord wallet typically, and by default, it creates an output of 10,000 sats. So understand that an inscription is written on top of, let's say, a single sat. But you can't just send one sat to someone because it's like the lowest the lowest amount in the Bitcoin currency is a Satoshi. So sending just one wouldn't make much sense, because then there wouldn't be much you could do with it, I suppose, is a good way to put it. So there are minimums that are required depending on the type of address that you have, whether it's a SegWit, Taproot, etc. But by default, because it sends 10,000, so it gives you one Satoshi with the inscription and 9,999 other Satoshis that are kind of like, some people call it padding, but I think the correct term is postage. So it's just there for just in case you need it, let's say. But if we do that, then things can get very expensive with a large collection. So for example, I have a converter here, and I've already put the 10,000 in there. So 10,000 sats equates to $5.19 at the current Bitcoin price. If you were to use the default, which is this, and then have a collection of 10,000, then your cost is going to be $51,900 just in terms of creating 10,000 individual outputs. And then on top of that, you have to pay the miners their fees, etc. So because the mint was pretty much free, it probably wouldn't have been possible to go this route, because you'd be putting up a lot of money and not recouping what you've put out. So what they've done, and what you can do using the Ord wallet, is set a custom postage value, and Harto and the team have opted to use 550. So 550 sats. Every Flora form has 550 sats, of which one sat, typically it's the first sat, is inscribed with the actual content. In other words, this. And you can see it because this should say, Magic Eden should show you the sat number. So that is the exact single sat that this is inscribed on. But when it was sent to me, when I purchased it and I received it, it came with 549 other sats in like a package, let's say. So going back to the calculations, so 550 sats would only cost 28.5 cents. Now it's more affordable to do a 10,000 collection this way. So they've saved a lot of money by reducing the size of the output. And this is a technique that is pretty common these days. I think I've seen it being used more and more frequently, just to make it more efficient as well. So I was also going to talk about how the individual pieces are able to be randomized. So if we have a look at the collection page, there are many different colors and things like that. But if you think about it, since each inscription is referencing the same parent, what differentiates each inscription to give them different outputs? And the answer to that is, you may have seen it when I looked at the source code of the Flora form. There is a value here, a variable that's set called seed. So var means variable, seed equals, and it has a very specific value. So if I take another inscription, another different Flora form, and have a look at it in Ord Explorer, this one's my one, and you can see the seed is OX4A9C. But this one, on the other hand, I don't know who this belongs to, but if I look at the code here, the seed is OXB619. So it's different, isn't it? And this is the magic, and this is what helps the parent script draw different outputs. So you can think of like a seed, like even if you had the same type of flower and you were to plant 20 different seeds of the same type of flower, they're all going to come out a little bit different, aren't they? So it's like that. In the seed is slightly different, and therefore you do get a different result. So obviously the output is a lot different in this case, and it's good that it is. But I'm going to show you how the script is accessing this. So how can this be fed into what we saw here? So this script here. So if we have a look through this code, there is a section that talks about setting up everything. So function setup, and it has a function called random seed, get seed, and the parameter is window.seed. And this window dot, so window dot is actually part of JavaScript's browser object model, and I'll bring you to the W3 Schools explanation page and the JavaScript window, the browser object model. The browser object model allows JavaScript to talk to the browser. And there's a line here that says, all global JavaScript objects, functions, and variables automatically become members of the window object. And then they can be accessed by using window.such. So it mentions variable here. And I showed you that in the code, there is a variable called seed. So therefore, window.seed refers to this variable, and that's how it can access this value. So back to the code where it says window.seed, you can replace this with whatever this value is, and then it's unique for each instance. And that sort of lays the foundations of building the randomization on top of it. And then it would go through the rest of the code, and then it'd be able to pick out whatever these different values end up being. So that's pretty clever. I think that the inscription itself being so small, so light, but then it lends itself on other inscriptions that have already been created is a very efficient way to do things. It's cost effective. It doesn't clutter up the network. It's beautiful. I mean, you look at this thing. I downloaded it and it was 15 megs, but then the actual code is 160 bytes. So I think this mint was a great success. Big congratulations to Harto and the team. And I might just throw in a little side note about On-Chain Monkey. And I know that Danny's been talking a lot about the parent-child and recursion and all these things that you're seeing being put into play, into action, and benefiting projects, founders, and the community, actually, because without these techniques, perhaps the mint price would have been a lot more. So now that these techniques and features that were being spoken about a year ago, 6 months ago, they're starting to become more widely used. I think that's a great sign for the entire Ordinals community. And we can all look forward to future collections making use of the same things or even newer stuff if they come out. In relation to parent-child, I think that's one area where it's almost a prerequisite. You know, it's almost a must-have for any new collection so that you can prove that your item belongs officially to a collection. So that's going to be about it. Hopefully it wasn't too long, and hopefully you understood how your Flora Forms are created and how beautiful they are, both on the outside, the final product, and also the code behind it. If you wanted to look into how the actual transactions were done on the Bitcoin blockchain, that's another area that's really interesting to look at. But I feel like that might bore some people because it is quite technical. But at the same time, because it relies on a lot of numbers, it's kind of easy to understand in the end of it. Like by the end of it, once you add things up and you can see that the left hand side matches the right hand side, etc. But maybe in another video I might do that. But for today, that'll be all. By the way, I'm working on my own collection of sorts, which I can't tell you what the idea is, but it might take a couple of months, but I think it's a pretty cool idea. And yeah, hopefully I'll be able to get it done and invite you all to come and check it out. So until then, that's it from me for now. Thanks for watching. And if you enjoyed it or if you found it helpful, please share. Otherwise, stay safe. Don't fall for scams and phishing links and stuff like that. And I'll catch you next time. Bye-bye.